Factoring trinomials with a coefficient on x squared and a positive constant. Here's where factoring starts to get a little more complicated. It's still going to be the product of two binomials. And these first terms in each binomial still have a product of your leading term in your original polynomial. So in this case, really our only option is 3x and x. Or you could do x and 3x, it doesn't matter. But the only factors of 3x squared are 3x and x. So that part's not too bad. Here's where it gets complicated though, because you can no longer just find the factors of 7 that have a sum of negative 22. Now, yes, these numbers are still going to be factors of 7 because they still have to have the product of 7. But now your middle term comes from the product, or the sum actually, of the products of your outer and inner terms. So this one's not too bad. You could probably just guess and check and figure it out. Because again, the only factors of 7 are 1 and 7. And then I know that they have to be negative numbers because I have to get a negative sum in the middle. So I can't just use all positive numbers. Then I wouldn't get a negative term in the middle. So they both have to be negative so that my product is positive. So I know that then the only numbers I can use are negative 1 and negative 7 because the only factors of 7 are 1 and 7. And again, they have to be negative to get this negative middle term. So the question is, where do they go? Is it negative 1 and negative 7 or negative 7 and negative 1? And like I said before, your middle term is the sum of the products of your outer terms and your inner terms. So that's how I know to put the negative 7 here and the negative 1 here. Because 3x times negative 7 is negative 21, negative 1 times x is negative 1x, and negative 21x plus negative 1x is your middle term, negative 22x. And negative 1 times negative 7 is positive 7. Now, of course, you can multiply those binomials together to check and make sure that you've put all the factors in the right place. So on that one, guessing and checking is fine. It doesn't take too long. You can kind of reason through it, use logic, and figure it out. But it won't always be that easy. For instance, here's one that's a little bit more difficult because our leading term is 6x squared. And 6x squared could be x times 6x or 2x times 3x. So we've got more factors to deal with here. So I want to show you a method that you can use to avoid having to guess and check. And that is to factor by grouping. And the first thing you would do is multiply your first term times your last term, 6 times 5, which is 30. And now you're going to find the factors of 30 that have a sum of your middle term 17. So this is reminiscent of when you were factoring without a leading coefficient. You'd find the factors of 5 that have a sum of 17. So the only difference here is now that you have that leading coefficient, you just need to multiply it times your constant. Okay, so let's find the factors of 30 that have a sum of 17. Since everything's positive, we're just going to use positive numbers. So it could be 1 and 30 or 2 and 15, and there it is, so we can stop there. Now, instead of going right to writing our binomials, we're going to use those to rewrite this trinomial. We're not ready to write our binomial because we still don't know what if 6x squared is x times 6x or 2x times 3x. So that's why we're not writing our binomial right now. We're going to use these factors to rewrite this trinomial as 6x squared plus 2x plus 15x plus 5. So what we've done is we're using these factors to expand our middle term. And the reason we're going to do that is it's going to help us do the factoring by grouping. Because now we can group our 6x squared and 2x together and our 15x and our 5 together. You see we have those two groups. Now we're going to find the GCF of each group. The GCF of 6x squared plus 2x is 2x. 2x times 3x would be 6x squared plus 1. 2x times 1 is 2x. So all we did was factor this first group by factoring out the GCF. We're going to do the same thing to this second group. The GCF of 15x and 5 is 5, a positive 5. And positive 5 times 3x is 15x. Positive 5 times positive 1 is positive 5. Notice how these factors are matching. So those factors are actually our GCF of our expression here. So now we're going to factor out that GCF, 3x plus 1. When we factor out that GCF, we're left with 2x plus 5. And that is our trinomial factored. You can FOIL it to check and see that it really is 6x squared plus 17x plus 5. That method to me is just so much better than guessing and checking with numbers until you find the answer. But you could have done that. You could have said, okay, I know I'm looking for these two binomials, and it's either going to be x and 6x, or it's going to be 2x and 3x. I know that those last numbers have to be the factors of 5, so my only options are 1 and 5, or 5 and 1. And then you can just play with it. You'll do a lot of FOILing, but you could see, okay, well, let's see. That's 5x and 6x, so that would be a middle term of 11x, and that's not my middle term. All right, let me try something else. And you could switch these around and try something else. Put the 1 there and the 5 there. So you've got x and 30x, which would be 31x. Still not there. Well, now that you've tried that, you know that it's not going to be x and 6x, so you could try 2x and 3x. That's 2x and 15x, which is 17x, and then you found your answer. So you still can use the guessing and checking. It just takes a little longer. And then if your numbers are even bigger than they are here, and they have even more factors, your first term and your last term, if they have even more factors, then it gets even harder to guess and check. So that's why I like this factoring by grouping method. So there you have factoring trinomials when you have a coefficient on x squared and a positive constant.